All right, we're live, so we're just gonna get started. Awesome. Hey everyone, welcome back to another True Story debate. And I'm super excited today to host two people that I really respect in the crypto space, both Muneeb Ali from Blockstack and Zaki Manian from Tendermint and Cosmos. And the topic that we picked today that we want to debate is this idea of the world computer. And Muneeb, I think a few months ago, went on Twitter and claimed that he doesn't believe in the idea of the building a world computer. He thought it was a waste of time, and he thought that it kind of derailed Web3 development. But Zaki, on the other hand, thinks that this is a totally worthwhile goal to pursue, and that it's not a waste of time, and that we should totally still go after this vision to build a world computer. So the two of them are going to battle it out today to talk about why they think it's a worthy goal or not. And so we're just going to get started. But before we get into that, I want to give them both a chance to give introductions of themselves for 30 seconds. So Muneeb, do you want to go first? Just give a quick background of yourself.
Sure. So, hi everyone. I'm Muneeb, co-founder of Blockstack. My background is mostly distributed systems. I did a PhD in computer science at Princeton University. Before that, I spent almost like a decade doing research work in peer-to-peer systems, cloud computing, and generally from the branch of computer science that deals with large-scale networks and operating systems.
Awesome. And Zaki?
I'm Zaki Manian. I'm head of research at Tendermint. I've been involved in the blockchain scene since about 2014. Before I got into blockchains, I didn't know anything about any of this stuff. Sort of taught myself cryptography, distributed systems, consensus algorithms, like all of this stuff as I went along. I've been, helping with various efforts to build like sort of world computer things, sort of all the way back to kind of like early Ethereum and Definity. I was pretty critical of the sort of early Ethereum design for reasons that have mostly been borne out, but I am cautiously optimistic about new world computer designs.
Awesome. Well, excited to have you both. And if you haven't yet, I'd encourage you to retweet the live link on Twitter so that more people can join. But we're going to get started. And the first question I have for you is this. I don't think a lot of the people may not have an understanding of what we are even talking about when we say world computer. So Muneeb, when you say world computer, are you referring to Ethereum's original vision, or what do you mean by world computer?
Yeah, I do think it can be traced back to the Ethereum white paper. So let me just say upfront that I think Vitalik is a very intelligent person. He is not a distributed systems expert, or at least at the time when he started Ethereum, right? Like I think he spent a lot of time trying to learn about these things. He was very young. And the original Ethereum white paper pretty much like set the vision for what Ethereum wants to do, but I think more importantly, also for a lot of other people who entered this space as well, right? So it's like they look at Ethereum or what the goals were, and then they try to pretty much like follow the same path and try to do certain things better, try to make improvements. And if you look at that original paper talking about the world computer, like from a computer science perspective, like it's pretty much like, pie in the sky kind of ideas, like very hard to actually implement, like filled with like deep, very, very um, sophisticated computer science problems that need to be ironed out, or some potentially can never be ironed out. And that to me was kind of like the start of the idea, and a lot of money, effort, and time went into these approaches. And sure, like you can keep tweaking things. You can like um, try to go from like if you're at one extreme end of the spectrum, you can try to go on the other side. But the question really is that should we have even started at that extreme end of the spectrum? And maybe things would have been like much easier if we did it.
So when we talk about this world computer and this extreme end of the spectrum, what was like the vision for it? Like how was this world computer supposed to work?
Sure. So I think it's basically this idea that there can be a system, a blockchain, where that can run all the programs for everyone and can store the data for everyone, right? So you are effectively writing these smart contracts. There's global state. and you can write anything you want. So the programming languages are general purpose, and people are thinking like, so I've been to like, lots of hackathons where young developers, they would basically write some application, and in their mind, when they publish it to a blockchain like Ethereum, like the Ethereum blockchain would magically take care of everything, right? All the computation, all the data storage, all the scalability is just like done. To them, it seems like AWS or something like that, right? Whereas that's almost like the exact opposite of what the reality is.
Interesting.
So I think the opportunity to contrast the world computer with AWS is probably like the most useful like way of making this at least approachable to ordinary developers. I think it's a little, the context I would put it for ordinary people is probably different. So the world so AWS is not a world computer. It is a huge computer. You can think of the entire AWS system as one giant logical unit. So it is one computer in a sense. But what AWS gives you is a computer, like, is a system for elastically giving computation to everyone, but it's delegating that control of that computation to the user who pays for Amazon services. The idea of the world computer is this is a computer that not only is accessible and available to the world, but is controlled by the world. That there is no controller and everyone in the world can view and believe the data in that computer in a way that, like, just because you update something in your AWS database, you have root on that database. You can change the database to be whatever you want. No one has root on Ethereum, and it takes enormous social consensus to do an invalid state transition like the DAO hard fork.
So Zaki, you're saying that you don't agree with the analogy, the AWS analogy of world.
No, I think it's actually a really useful analogy. Okay. I think Muneeb is totally on the ball in the way that it's marketed, the initial marketing of Ethereum was like there's so much that Ethereum got wrong in its early days, including like everything about its original design. But I think there's an enormous amount of value to seeing where it found product market fit, where you see glimmerings of real use, and like why those are special. And so like I was very critical at the time of like, a lot of Ethereum design decisions, but it doesn't diminish the fact that like in 5+ years afterwards, like I learned so much from seeing Ethereum live, seeing Ethereum become stable, that I would not have understood about the world if Ethereum did not exist.
Somebody like, what's your pushback? Your main pushback on the world computer idea is that it's too idealistic. Is that right?
I think yes, it's very, very idealistic, kind of like tries to hide all of the actual real technical challenges and just assumes that, oh, this thing might be possible. Let me backtrack a little bit.
Sure.
Right? Like whenever some core technological progress happens, there's some technical breakthrough behind it, right? And you usually get a community of engineers and scientists coming together, building on that. Like just looking at, let's say, operating systems or even cloud computing. So for cloud computing, the main breakthrough was virtualization, right? So you could virtualize on top of bare metal, and that technology, like there was a very sophisticated community around it who understood what virtualization is, and they were working on improving that, right? So a lot of like my conversations, like I do engage in crypto, but a lot of my life is actually outside of crypto. So most of the computer science conferences that I go to, people wouldn't touch this thing with a 10-foot pole, right? Like people just like laugh at you. And obviously there are other issues involved, like the ICO craze and the get rich quick kind of image that we have of crypto. But even if someone can look past that, they glance at the technology and they're like, how can people take this seriously, right? Like let's just take one thing, for example, this idea of global state, right? That anytime there is any state change in most blockchains, you're supposed to sync that with globally with everyone on the network. And in fact, there is almost like an arms race. Like every other day, I come across some project that tries to say that our transactions per second are God knows how much, right? Like there are these metrics around these things, and no one is asking the question that should there be global state to begin with? Because most distributed systems people would say, no, you can't have global state at all, right? Like maybe for very few things you can have global state, but you should be working on localizing your state as much as possible, right? So it's almost like the exact opposite design principle that is usually used to scale distributed systems, databases, and so on and so forth. Uh, and and I think my issue is also a little bit like it. The way it attracted the kind of people was also like a lot of sophisticated engineers just like stayed away from the space, and they still do, right? Like they don't engage, and we have to work very hard to convince them to actually enter the space.
So there's two things that you mentioned here. One is that you just don't think the idea of a global state is realistic. And so Zaki, I'm curious to hear, like, what do you think about that? Do you think a global state, it's like almost, yeah, it's unrealistic?
So I think there's two components, and they're somewhat related. One is what I think is probably like what will be viewed in hindsight as an enormous oversight by the academic distributed systems community, in how to, and like what are the parameters around which you design these systems, and then is the related concept of why these things are useful. So I'll reverse the order and start with why is like what is the utility that we're going for? What is the utility that we've kind of like teased out is the usefulness of a system like Ethereum. And mostly what we have found is that what we're looking for is a super credible data store, or actually data store isn't just it's not just a data store, it is a state transition function. So we want a state transition function. What we're asking the system for is a state transition function that will never deviate from what has been programmed in under extreme conditions. And that's the value prop. So the reason why this is useful is it solves a bunch of long-standing problems that have existed in cryptography and distributed systems around ideas like fair exchange. So what we've been looking for a long time in the design of these systems is like an impartial judge that can watch that like the entire world watches and is like the Supreme Court of the internet. And in the Supreme Court of the internet, you present your evidence. The judge analyzes that evidence and then renders its verdict, punishing the misbehaving party. And this enables all kinds of things. Lightning is like a good example of it. Vitalik's ideas around plasma have elements of it. But when I design systems, this is the property that I'm looking for. It's incredibly valuable for building, for incentivizing human economic relations.
But I think isn't Muneeb arguing that like I think Muneeb, just correct me if I'm wrong, you're saying distributed systems people, credible distributed systems people don't think this is even possible.
No, I think the if you severely limit the size of the data set, so I completely agree with Zaki that it's very valuable to have some global state on which everyone can agree that it's very hard to change that state. Like let's take Bitcoin for example, right? There is some state that represents, Bitcoins you own, and everyone can agree on what that state is. And it's a fairly limited set of state, right? And Bitcoin community have had their own arguments around, block sizes, which in a way was trying to push more state into the system, and that community kind of like forked off and have their own mini kind of community now. But I think the starting point is, the question to ask is, how much state are you talking about, right? Because in the Web3, blockchain, Ethereum-like communities, they're literally talking about all the state on the internet, right? They're not talking about a very small subset of that state.
Okay, let me tackle this. So we agree that some amount of global state and like a very difficult default state transition function is a valuable social good. It's like a valuable public good. Okay, so I wanted to cover just like one other thing that I think is like represents a little bit of why this has been such a struggle. There is a thing that people in the community have started to call the data availability problem. And it is a thing that there is essentially no pre-existing academic literature about. And it is basically the problem of, okay, like there exists some data on the internet. How do I know that it's available to all the parties? And the way in which proof of work in Nakamoto consensus achieves this, assuming that there isn't a 51% coalition, has been sort of like one of the more interesting problems. But if you look at consensus literature, and all of our consensus researchers at Tendermint and Cosmos like consistently come back to this as like as a challenge for their work, because we are expecting our blockchains to provide properties that aren't well described in 40 years of BFT consensus, which is how do you know that your counterparty is actually able to see the data that you came to consensus on. So then the central question is like, what are the problems that you have to solve in order for the state, the global state that we're working with? What are the problems that you have to solve for it to be large? Can we make a list of those problems? And then can we demonstrate that we are making progress towards solutions to those problems if that state is going to be large? And I would say that we have made enough progress on those technical components to reasonably assume that a large state can be provided in that public good of a highly available, high security database.
Interesting. So just to summarize, if I understand you correctly, Zaki, you're saying Muneeb was saying that like we both agree on the fact that having some kind of global state is valuable and it's a good public good. It's something that we find value in. But I think Muneeb's argument is that Ethereum's way of thinking about global state is literally put everything on the internet onto one state machine.
So let's put hard numbers on it.
Yeah.
So like, I believe the Bitcoin current state, the like entire UTXO set, which is the current state of Bitcoin, is about 80 megabytes right now, something on that order. Yeah. I don't have the number off the top of my head of the Ethereum current state. My point of view is that it will be possible to build systems with similar guarantees to Bitcoin that store many gigabytes or terabytes of data. But I don't think we could do it with petabytes of data, as in all data on the internet.
Got it. Muneeb, do you agree with that?
Yeah, so let me go back to the availability discussion that Zaki was happening. So availability is a classic thing in distributed systems, even like going back to, if you look at, I think some people bring up the CAP theorem that Eric Brewer has. He's a Berkeley professor. I think he proposed that in like 1998, presented it at PODC in 1999. One of the things in CAP is A stands for availability, right? So people have been, so I disagree that distributed systems people don't think about availability or it's something new in
data availability is a different thing than liveness. Like what you're describing is liveness and consensus, and data availability is a different thing.
How is it different?
So liveness and consensus is like, is your system going to continue to advance and come to agreement? Data availability is, how do you know parties that are not participants in consensus have access to the data, or like are reasonably likely to have access to the data, or the non-participating set? So like, let's say you have a consensus algorithm that is going along, and you can, and let's say a party behaves maliciously and you exceed your fault tolerance threshold, and you fork the network. So there's 2 forks. So you can say the idea is, I want to slash the offending party. I want to punish them. I have cryptographic evidence of their faults. But because I don't know that the data is available, I don't know that I actually have the evidence to punish them. So this is a significantly different problem. Like liveness, again, is like agreed, well understood. We have 40 years of research, and like your criticism of CVC Casper as not providing the liveness proof, totally spot on. But the larger problem that like is really hard when you're building these systems and expecting them to provide highly reliable state transition functions is you have to consider the situation in which they fail. And that is where the situation where this question around data availability becomes hard, and has been like the thing that I think most people who are working on scalable world computers spend most of their time thinking.
I can for the audience, I can give you like the more classic definition of availability. Availability is usually in a distributed system that if you want to talk to a system, you can get a response from, right?
Yep.
So it's just that, is that data there, right? So the problem you're running into with these large data sets is that you don't even know if any copy of that data is available at all, right? So
Exactly.
let's take EOS as an example, which basically doubled down on Ethereum's design, and they were like, we'll build a world computer that is faster or whatever, can even have like long running programs and things like that. And in reality, like even out of the 21 nodes that they were trying to have as block producers, even 4 of them were trying to keep the full copy of that data, right? And that's the kind of problems you run into if you're trying to push too much global state into the system. And I would maintain that availability is a well understood classic thing in distributed systems. You literally deal with it regardless of like what type of system you're trying to design. Could be a database, could be just like some sort of a consensus protocol. Like you hit the same concepts, and those concepts have kind of like same meanings in distributed systems as well. One of the things that has been challenging for me in crypto has been also like people kind of like inventing new terms or using terms in ways that they actually don't, they're not used traditionally. So you kind of like wraps your mind a little bit. And sometimes like, I think it's fine if you come up with new terms, but at least like we should try to all agree on like what these terms mean, right? Like I don't think we're at a stage in crypto yet where we have that kind of consensus. I think I want to kind of like go back to the broader topic of the debate a little bit, and try to like basically tell the audience broadly about what's the difference between kind of like the having a world computer or not having a world computer, right? First of all, like think of this as scalability challenges are a classic thing in computer science. Any system you're working on, you would be working on scalability challenges, right? So it's not like something odd or new in crypto that you're working on scalability challenges. Like Google's search engine to us like might seem like magic that every time we have a query, like you get a response. Google has gone over iterations and decades of design of like scaling out their various systems, and though they're rooted in like deep distributed systems principles, right? And you can look at a system, and anyone who understands distributed systems can understand those systems and can help potentially improve them, right? So as a community, you're actually iteratively getting better because you're standing on solid foundations or common grounds. We don't even have that in crypto, right? Like because some of these systems they don't make sense. Let me give you an example. So with this global state type of system design, I've seen versions of like Twitter built on top of Ethereum, where every tweet is a transaction at the blockchain layer, which causes a state transition for every single node that is processing Ethereum, right? So imagine that you are not running that. You're not interested in, let alone like that person who is tweeting, you're not interested in Twitter as an application, right? if you're participating on Ethereum, you're getting slowed down by that person tweeting, right? This is a kind of like the biggest scalability challenge over there, that every node is processing every single state transition, right? And it you can just do like back of the envelope calculations to figure out like how much data would that mean, how much bandwidth you would require for realistic applications like Twitter does, like hundreds of millions of tweets. You can't even get anywhere close to that with these systems. So that's the main thing. Versus the way that Twitter is built today is very different from such like world computer kind of architectures.
Interesting. So you're saying basically that one of the flaws with the world computer is that like because you're building a bunch of all the applications on one world computer, every other application suffers from every new application that's built on top of it. So yeah, so I think that's something that we can all reasonably agree on is not good, where like just because Twitter decides to build on Ethereum doesn't mean the entire Ethereum network should get slower. But like if that's the case, then what do you envision a better way to build the decentralized web?
Sure.
Go ahead.
Sorry.
Yeah, I think going back to this concept of like global state versus localized state, I think a very obvious thing to do would be to localize the state as much as possible, almost by default, right? So if I'm running a decentralized app, my actions shouldn't slow other people down unless I'm making some sort of a state change that absolutely needs to be global, right? So an example of that could be if I'm moving money around, or if I'm registering some sort of a global username, or you can like come up with what I think the lens is that by default things shouldn't be global, and then you have to justify why does this particular state change needs to be global. Whereas with the world computer approach, the lens is everything by default is global, and then they're trying to figure out how to scale it, right? Like, and there are all sorts of like these different approaches to try and scale that.
I'm curious, Zaki, like where do you disagree with Muneeb on this, if at all?
So I guess my point of view is, yes, I would like, so the point of view is two. It's like, one is like higher layer systems that like localize data and don't require global consensus are like essential to making this kinds of systems that I want to build like available to the entire world. But on the other hand, I do want a global state that can hold the entire world's, like that can hold things of meaning to the entire world. And that needs to be on the order of terabytes, not on the order of megabytes. In my, like there isn't enough space in Bitcoin for every human on Earth to hold a UTXO. Like we need larger state transitions if we want to make this, like these ideas around crypto economics that like we're spending our time on accessible to the entire world. So I do think like base layer system design. Now, like with Cosmos is not a world computer design. Cosmos is tiny, medium credibility computers that are connected, and that's a more scalable architecture. But it still doesn't fully scratch the itch. And so what I think is valuable is that the like it's sort of, the question, like the comparison to like something like Google is sort of an interesting one to me, because when I think about Google, there's actually like direct analogies between what Google is like, how Google is designed, and how we are trying to build these like Web3 hyperscalable computers. So Google has a global database called Spanner, which is amazing. It has atomic clocks that maintain transaction consistency across a global set of data centers. You can have very strong guarantees about view consistency on that data, whether you're viewing it from Malaysia or San Francisco. It's an incredible system. But if you think about how it works, it's consensus algorithms, it's timekeeping, it's sharding of data. And what are we trying to build in the decentralized Web3 world? We're building decentralized clocks that are super reliable, That's is why we're spending all this time and energy on verifiable delay functions. We're trying to build consensus algorithms that are fast in distributed settings. So like Tendermint and Avalanche come to mind. We are trying to build like ways in which we can reconcile and check data for errors. So like you use conventional error correcting codes in like high reliability data stores like ZFS or Spanner, or like whatever backs the Spanner database to like prevent bit rot. We are trying to build malicious, like adaptive adversary resilient versions of this. So there is a sense in which what we are trying to do is build a Google scale system, but for the general public. And I do think that is a viable research goal and like a thing that can exist.
Interesting. What do you think, Muneeb?
So I think it's interesting that we're discussing Spanner or other such systems. If you look at Google Spanner, I believe it was published at OSDI 2012. Similar other systems. So Amazon has done a bunch of work on their Dynamo system. I believe it was published at like SOSP 2007. I think I was at that event. The thing I would point out over here is I don't think people in crypto have ever even heard of these conferences, right? Let alone if they ever go there, right? And that's the place where scalable distributed systems get built. And there is an entire community of researchers there that understand these problems very deeply, and they can actually help the community or point out like here are very glaring flaws in what work is currently going on. And I would say that such people, such distributed systems experts in crypto are so rare and few that if they say something, and crypto is a little bit like religion as well, that if you are a supporter of a project, a lot of people will start, criticizing you or yelling at you, which interestingly, if the other party is also saying anything technical, to the broader audience, both things just sound technical, right? They can't tell the difference between like one technical argument versus some other technical argument, right? That doesn't mean that like the arguments are equal, right? There's a huge difference. I think we got pulled into this at some point. I think Zaki mentioned the Casper CBC paper. We did a review of it, and the review was pretty much like people can read that paper. And again, I think Vlad is a very intelligent person. I think he's been spending a lot of time on some of these problems as well. But if you just put your computer science hat there, you look at what the paper does, and you look at, let's say you make a list of like things you need to prove to be able to have a BFT protocol. And you take a look at like what the paper actually does. The paper doesn't even come close to doing anything like that, right? But a normal audience wouldn't be able to differentiate that. They would just look at the paper, they'll see a bunch of math proofs, and they'll be like, yes, it looks like we have made a lot of progress on a consensus protocol, whereas in reality, you haven't. And I think that's the thing where I would love to actually put out a challenge that why don't the crypto community try to publish some of these designs at these conferences? Like SOSP is one of them, OSDI is another, right? There's a peer review process. Those people don't own any crypto. Try to get review from that community and see what they come back with. Like the average, I think the average time and effort that goes into a single SOSP paper is something like 5 years of work. And I think that those resources are available. Like all projects have to do is try and submit and see what these impartial reviewers would come back with.
Interesting. So I think the argument that you're making, Muneeb, is that if Zaki kind of brought up Google Spanner, and I'm curious to hear do we think that the traditional distributed systems experts at companies like Google would be accepting of Ethereum's World Computer design? And that's an interesting question that I would have myself as well. Would they be approving of this, Zaki, or do you think they're also kind of far behind? That's a fair point that Monique makes, right?
So okay, so a couple of things like in blockchain distributed systems world, like Tendermint was like probably like one of the first things that like has like done peer review from that world. And so like, proud of that effort. And like one of the things that was like, I think particularly problematic from a review point of view for a long time was that like a lot of this discussion was never written down, or like, Dfinity has like both hired a lot of very credible people from this world, from like the conventional engineering and computer science world, but like never open sources or publishes any of their work except in like highly abstract academic like venues. But like one thing that I think is like kind of represents progress as a space is like the Ethereum 2.0 design is like enormous effort is being made to write it down. And then also in terms of like serious engineers like who are spending time on this, I would also point out like the Near Protocol team. They're basically the founding engineering team from MemSQL, which was a team that built like a widely well-regarded like distributed database that provides like like SQL guarantees and distributed joins over like extremely large data, and is widely used by like large-scale industrial users.
Does that give you a little bit more confidence that Near Protocol engineers are thinking and designing Ethereum 2.0 World Computer?
Well, I think like the near vision of a world computer, like that's a team that's like qualified to build this kind of thing.
Yeah.
And
so I do think the quality of engineers entering crypto has been going up over the years. I think the main thing is that like once an industry like starts going in a certain direction, like it has momentum and inertia, right? So my stance is that it's almost like, I think I have a blog post draft that I may publish. It's called Unlearning Ethereum, right? So there are many very core concepts that people have started taking for granted that are actually bad ideas, and you can trace the origins of them back to Ethereum, right? I can give you an example. Like for example, the only programming interface available for working with blockchains are smart contracts, right? So literally, like everything, people automatically assume that everything needs to be a smart contract. It doesn't, right? Like the programming languages have been around for like 20, 30 years. Before that, there are only a very small subset of things that need to be expressed as a smart contract. But this idea also, again, goes back to Ethereum. Same with the idea of global state. I don't think people have a lens of global state is bad, I'm going to try and minimize global state as much as possible. Like if I was designing a system like this, and typically what people do is they would first try to figure out what constraints are you operating under, right? So the constraints in this case would be you would look at the geographic distribution of nodes. You would try to come up with, this is the average node. Like the average node would have this much memory, this much hard disk, this much uplink bandwidth, this much downlink bandwidth. And my global state has to operate within those constraints. And those are pretty much like hard constraints. Most of them are physical, like bandwidth is a physical constraint. Memory and disk you can project into the future as well. Like we have a lot of data on that. And once you look at those constraints, every protocol has to operate in those constraints. Those constraints are not going to change at all, right? So I don't see efforts which basically like hard numbers around what the global state really looks like, and then what's realistic. Like what can we put at the core base layer? And sure, I think sometimes like my comments also come across as like Muneeb thinks that base layer protocols are never going to improve. Like that's absolutely not the case. There are going to be new types of protocols. They will be faster, but my point is a little bit higher level from there. That if we are thinking that Web3 is going to take over and replace Web2, the underlying architecture might need to look very different from a lot of approaches that we see in the industry right now.
Interesting. What do you think about that, Zaki?
let's see. So it's like yes and no. Like I'm just sort of like shocked and impressed at the level of progress that has been made in the last like 5 years. Because coming into this space, it was exactly that. Like there was a bunch of young people, nobody with appropriate skill sets, people who had never heard of things like Paxos or like built a consensus algorithm, and mostly people who had never built or shipped a real thing. Like in the entirety of like pre-launch Tendermint, like me and Jay are the only people who'd ever built like a thing before and shipped it to customers. So like we work with these like extremely young engineers. But my perspective has shifted over the years of working with different teams in this space about what might be possible and like what is short-term possible. I think yes, the long-term architecture of these things has to be bent towards minimizing global state. But like it may turn out that it was an efficient allocation of resources to kind of throw a billion, hundreds of millions of dollars at different approaches to scalable global state just to see how far we could push things and what were the different engineering trade-offs. And we end up with half a dozen real systems that work at scale and make different trade-offs in the space. And then we know what the limits are we actually have fully articulated the limits of the layer 1 system. And then we can figure out what the layer 2 system actually needs to look like based on those limits, rather than sort of prematurely optimizing for an extremely minimal layer 1, like what Bitcoin and current Ethereum offer us.
Got it. So basically you're saying that you realize that there's limitations and there's constraints that we have to build the system on, but your take is it's worth exploring what that, like pushing the boundaries of what these constraints offer to see what's possible, rather than trying to operate under those constraints only.
Like the constraints that exist in version 1 of the system.
Version 1, okay. And Muneeb, would you agree with that, or where do you differ in this point of view?
I think it's great that the way I make my peace with a lot of these different ideas is that it's experimentation and it's good. Some good might come out of it. I think where I get concerned are two things. One, young developers who come in and they want to learn about some of these blockchains, and if they have like really unrealistic expectations, right? You're misinforming those developers, and they don't know any better, right? Like I've been to countless conferences where there would be some young ambitious person who is like learning to write like smart contracts and would have like a 5-10 minute discussion with me, and their jaw would be like, what, seriously, like this, like it wouldn't work that way. They just don't know any better, right? So I think there are people who have been in the space longer or who understand the limitations of these systems should do a much better job at setting the right expectations, right? If you look at some of the marketing material of these projects, I think the marketing material is responsible for then people having ideas like, I'm going to put X on the blockchain, and this is like a magical machine that is just going to do everything, right? So I think regardless of the technical approaches, definitely we need to improve on setting expectations and better communicating the current constraints of all these systems. The second thing is that I think we should, again, experimentation is great, but we should ask ourselves, like, what's the goal? What are we trying to achieve, right? If the goal is that we want a decentralized Web3, right? Are these resources and time and effort better spent in a different direction, right? Because I think it's safe to say we can agree that most people currently in our industry are spending time trying to build the world computer. There are more projects and more money and resources backing ETH 2.0 type or Definity type or EOS type systems, right? And I bucket all of them in the same category of like they're trying to build a world computer.
Yeah, absolutely.
And relatively, there are less resources that are being allocated to alternate architectures. And I think that's a misallocation of resources, because again, I'm obviously biased because the kind of architectures I'm working on are not in that category, and that's why I'm spending a lot of my time and energy there. But the end goal should be that if what we want is users to kind of like own their own information, not be dependent on these large companies, have some sort of a global layer where we can have on-chain logic. My pushback would be that you can get there faster because there are much easier paths available, right? If you just change the underlying architecture, and more people kind of like start working on this different set of things. And this is actually, by the way, it's a very classic thing. Even if you go back to operating systems, there used to be before Unix at MIT, there was an operating system called Multinix, which was actually very complicated, right? And the main thing that Unix did was it was like, let's just make the base layer very simple, right? So entire Unix design philosophy is your base layer is very simple, and you can do interesting things on top of it. Same thing happened with the internet. Like there used to be different versions of like these networks. Some of them are very complicated at the core of the network. Like there's active networking, and then one of the main things. So the chief protocol architect of the internet, David Clark, he has this design principle called the end-to-end design principle, and all it literally says is that keep the base or core of your network extremely simple, and let the complexity be at the edges, right? So those are tried and tested distributed systems design principles that can be used here as well. And we have seen that generally keeping the base as simple as possible tends to work better. And we are almost doing the exact opposite of it, right? And more people are in the other camp than the camp of like, hey, let's just keep the base very simple.
It's pretty compelling. I think you're making the argument that like a lot of people are working on this idea, but you want a little bit more shift in focus in following some of the traditional known approaches rather than everyone going after this lofty goal of the world computer. And I think there's something in between, right? Like even Zaki himself, he's leading the Cosmos effort, and I'd argue he's not going after the world computer idea, but I think what his argument is like it's worth pursuing. And I think where you both agree is like there's some limitation where the world computer could be built. And I think Muneeb's argument is we're spending too much resources in trying to meet that limitation. And I think Zaki's argument is like that those resources are worth it. But it's probably somewhere in between where some of I think like the key point that probably you want people to take away from this is that like the current architecture of Web3 is in no way the final set architecture. We might find and discover that like the Web3 architecture looks way different than what Ethereum 2.0 or Definity or some of these other blockchains look like. But I think like where I stand on this is like it's still like I don't think we should completely shun on people that are trying this world computer approach. But I do agree with Muneeb a little bit in that it's worth spending more resources trying to find new architectures. What about you? And so like I'm curious, Zaki, do you agree that there's like some unlearning that needs to be done and relearning and rethinking and being more creative of what Web3 can offer besides the Ethereum 2.0 approach?
So I think one of the things that I always find interesting is like Muneeb's goals and my goals are very different. Muneeb's goals are like users should own their own data, there should be increased user sovereignty, all of that stuff, which are laudable goals. My goal is to build a system that can scale to the size of global capital markets and provide like an entirely new framework to experiment with like human coordination problems. And so those are like really different goals. Muneeb is correct that you probably don't need a large world computer as much for his goal. And my goal needs something that starts to behave like a large world computer. The like Cosmos is a very different approach that involves shipping things that people can use at all stages of the process before arriving at a world computer. Whereas most other projects in this space have been making the mistake that was made with Multics. And I gave a whole talk about second system syndrome, which is sort of like been a term that was coined in reference to the failure of Multics at MIT, and how we kind of like the Cosmos approach has been to avoid it by like building like a simple thing, shipping it, having people use it, then build a little bit more complexity on top of it, shipping it. And like we've been doing this for the last 5 years, and I intend to keep doing it for the next 40. And eventually, I think what the sum of all of those pieces will look like is a world computer.
Interesting. So I think like maybe the real argument is like what we should be thinking about, like what should be stored on a world computer, and then only store those things on this world computer, but then like all the other apps and stuff that perhaps like Muneeb views as Web 3.0 should not be stored on the world computer. Because like those things, I don't know, like I think is that maybe a good way to look at it? Like depends on the type of data that we want to store on this computer.
So all I would say is like you look at True Story as an example.
Yeah.
Like True Story built on the Cosmos SDK, it exists in this space that is more credible than a system that exists on AWS or Amazon, has a more difficult default state transition function, but isn't the enormous cost and expense at operating at the difficulty of the state transition function on top of Ethereum. And like one of the spaces that I've been trying to carve out is the space in between AWS, stronger guarantees than AWS, and weaker guarantees than Ethereum, which I think is like a useful space to like flesh out. And I think that, but like there is like ongoing work about trying to scale the stronger guarantees of Ethereum, and I also participate in that. And you know, this is my point of view, is that there's going to be this continuum. Apps will choose. We need to make the entire continuum available to developers at scale in order to like realize the vision.
Fair enough. So then I want to give you both a minute to kind of make your closing statement and kind of share, like, I think a good way to end this discussion is like how, if someone was new coming into the crypto space, like what would you tell them, what you envision the world Web 3.0 looking like in the future?
Go ahead. Who do you want to go first? It's your pick.
Zaki, go for it.
Okay. So what do I envision the world going forward? I envision a world in which there is fairly abundant access to extremely fault-tolerant computation, that we are able to program computers and manage state machines as communities that can manage everything from like a corporation's like cap table to collectives, like the flow of income between multiple members of the collective, that things like MakerDAO and like that like follow design patterns that you're seeing with like Compound and Maker scale to the size of the global economy and custody trillions of dollars of assets. Like this is the vision. This is what I want to build. And like I'm like the whole point of all of like the cryptography and distributed systems that like I've been interested in for the last 5 years is to like establish an infrastructure that makes this possible.
Awesome. What about you, Muneeb? How do you envision the Web3 world looking like?
I think for me, the Web3 world is a little bit like it makes your digital life work more closer to how real life works, right? Like in the sense that like property rights are a great example. Like you don't really have property rights online right now, but now with these blockchains, you could, like for example, directly own something. It could be a digital asset, it could be a username, it could be your data, and that, I think that's a very powerful concept. Similarly, like imagine if you're just having a conversation with a friend. No, there are no devices. You're sitting in your living room. You don't expect that thousands of people are just sitting there listening to your conversation, right? So in many ways, like you want, just like people can own their own home, they can have property rights. you can have these same things online as well. And a lot of the ideas around like smart contracts or on-chain logic, they also translate into the ability to directly connect and trade and be able to do things without going through these large third parties like banks, right? So basically, in a way, you're removing inefficiency from the system by removing data banks like Facebook or actual banks, and are automating a lot of that and enabling direct connections. And I think that's the kind of thing that really excites me.
Awesome. And then you believe that it's not a world computer approach, but a more traditional distributed system, smaller world computer approach. Whereas Zaki believes that he believes that, and plus still going after the world computer approach. So I think that's a good way to end this conversation. And I really enjoyed moderating the topic. I think this is not the end of it. This is just the beginning. As you know, we're just in the beginning of figuring out this whole, whether Web 3.0, how to even realize this Web 3.0 vision. So the goal of this conversation was mostly to start and spark a conversation, and we can continue to have debates about this in the future. And so,
one last thing about I think since this is about the world computer, I think I'm pretty much in the camp that as things evolve, a lot of the world computer ideas are actually going in the direction of like trying to build a very complicated mainframe, right? Like at a very high level, that thing can just give you all the computations you need. Whereas if you look at kind of like how even the internet evolved, it's not a single logical mainframe, right? It's lots of like small things connected with each other. So I'm more in the camp of like, it's not going to be a world computer like a mainframe. It's just going to be better connectivity of a lot of like smaller devices talking to each other.
Really good analogy. Really good analogy. Awesome. That's a really good ending. So thanks everyone for tuning in for the live debate. And again, the whole point of this conversation was to start the debate around. We'll have another live debate coming up next week. We'll announce it soon. And Muneeb and Zaki, thanks again for joining us today. We'll have a live link and everything available for people to rewatch it if they want to.
Cool. Thanks for listening. Thanks.
Thank you, Muneeb.
Awesome.
Have fun at the Berlin events.
Yeah, Zaki's at Web3, so Web 3.0 summit, so it's perfect timing.
Cool.
Cool.
Bye.
Bye.